In this program, we're going to demonstrate a typical and systematic procedure for testing a charging system featuring an alternator. As with any system, it helps to remember exactly what that system consists of and what it must do. So we'll begin with an overview of the charging system. Nowadays, most vehicles are equipped with an AC charging system, and the main component in the system is an alternator. An alternator produces alternating current, which is then rectified to become a DC current, which is required in automotive circuits. The function of an alternator is to keep the battery charged and to supply current to various loads whilst the engine is operating. A typical alternator consists of a stator and a rotor. The rotor rotates on bearings held within end brackets. The stator surrounds the rotor. Two end brackets support the rotor on its bearings and hold the stator in position. Current is supplied to the rotor windings via slip rings. Brushes carry the current to one slip ring and to earth via the other. We call this flow of electricity the field current. The field current is responsible for creating a magnetic field and an induced current into three large windings within the stator. The induced current is an alternating current, or AC, which needs thereafter to be changed to a direct current, or DC. This is achieved by a rectifier consisting of 6 diodes. A diode is like a one-way gate or valve, allowing current to flow in only one direction. The symbol for a diode is shown here. The arrow indicates the direction of current flow. The three-phase AC output of the stator flows into the rectifier. It gets converted to DC and is fed out of a single terminal where it supplies the battery. The system is shown here in schematic form. Note that an alternator system can only be used on vehicles that have a negative earth. Be aware that if you accidentally connect your battery for a positive earth, you will instantly destroy the rectifier. The battery requires differing degrees of charge. For example, after a starter operation, it will need a lot of charge, and the alternator will deliver a high output. However, once nearly charged, the battery doesn't need much input from the alternator. To take care of this, a voltage regulator situated within the alternator is used. This device in effect regulates the strength of the field current and thereby increases or decreases the alternator output. The voltage regulator senses the battery voltage and the alternator output. It then electronically changes the strength of the field depending upon the load requirement. A warning lamp on the dashboard or instrument panel lights up when the system is not operating, it goes off when it is operating, and it comes on to warn the operator if the system is faulty during operation. The warning lamp, also called a charge indicator, is connected via the ignition switch. The indicator lamp circuit routes a supply through the bulb and into the field connection as displayed in this simplified schematic. The circuit is completed via the regulator. When the engine is running, the alternator voltage increases to match that of the battery voltage, which effectively balances the voltage on both sides of the lamp. As there is now a zero potential difference in the lamp circuit, no current flows and the lamp goes out. We have described the basic principles of a typical AC charge circuit. Differences in design, circuitry, and layout will occur between the various vehicle and component manufacturers. For more detailed instruction on a particular make or system, you will have to consult the manufacturer's service manuals.